This section, we're going to talk about special distributions, normal distributions. Normal distribution is bell-shaped and symmetric about the vertical line through its center. So if we're looking at this picture right here, this is all types of normal distributions, and this is going to be mean. And from the mean, on the right side and left side, that's going to be symmetric. So on a vertical line, right and left will be the symmetric. Furthermore, that mean, median, and mode of the normal distributions are all equal and located at the center of the distribution. So this one right here is going to be mean. And mean, medians, and modes are all equals, then we can call that as normal distributions. And this picture also shows the three normal distributions with the same mean but different standard deviations. So between, if you have a larger difference or smaller difference, right, you're going to have different shapes of the bell-shaped graph for the normal distributions. But long as it say normal distributions, from the mean, right side and left side is symmetric. And we need to know a little bit about little rules on the normal distribution. It said approximately 68% of data it falls in first standard deviations of the mean. And approximately 95% of the data items fall in within 2 standard deviations of the mean, and approximately 99.7% of the data item fall in 3 standard deviation of the mean. And this shows you your standard deviation 1, 2, 3, right? 1, 2, 3. And your normal distributions area is going to be about 68% in between 1, and between 2 is going to be 95%, between 3 is going to be 99.7%. And example 1 is asking, male adult height in North America are approximately normally distributed. So in order to use your normal distributions, right, rules, the problem have to mention it's a normally distributed with the mean of 70. So your mean is given as 70 inches and standard deviations of 4 inches. Find the heights that is A, 2 standard deviations above the means, 3 and B, 3 standard deviation above the mean. So if we wanted to answer A first, find the height that is 2 standard deviations above the mean. What we need to do is we're going to do mean plus, so your mean was what, 70? Plus 2 standard deviation above, so will be 2 times your standard deviation, which is 4. And that's going to be 70 plus 8, so that is going to be 78. So we could say height of 78 inches is 2 standard deviation above the mean. That means if we wanted to find the B, 3 standard deviation below the mean, we're going to do mean minus 3 times the standard deviation. Below, that's what you're going to subtract. So then you get 70 minus 12, which is going to be 58. So we'll say the height of 58 inches is 3 standard deviation below the mean. So example 3 is asking, now using example 1 we just did, find the percentage of mean in North America with heights A, between 66 inches and 74 inches. B, between 70 to 74. C, above 78. Well, in order to find the percentage, I like to create my normal distributions graph first. So my normal distribution will look like the bell shape all the time. So let me draw the bell shape. And this problem, we have a mean of 70. And standard deviation is 4. So first standard deviation is 4, and we figure that out. This is going to be 7 plus 4, so it will be 74, right? And then second standard deviation is going to be plus 4 again, so it will be 78. And then you have 82. The other side, you're subtracting 4, your standard deviation. So 70 minus 4 is 66. And then you're going to get 62. And you have 58. And one other thing that we remember, that between first standard deviations, your difference is going to be, your percentile is going to be 68%. And then second ones, standard deviations, is going to be 95%. And third is going to be 99.7%, right? That was the rule we had if we go back to it, right? Remember this rule right here. First standard deviation, second and third, right? So using that, this is the number we get. And let's go back to example A. It said between 66 to 74. So 66 to 74, that's just the difference of the first standard deviations, right? So that's going to be 68%. So 68% of male adults have heights between 66 inches to 74 inches, right? And if we're looking at a B, it said between 70 to 74. So you're looking at from the mean to 74. Remember, because is on the right side of mean and left side of mean, values are going to be equivalent. If you're cutting half of 68, you're going to end up getting 34. So it will say 34% of men have height between 70 inches and 74 inches. Then what about C, above 78? Above 78, this is 78, and above is this direction, right? So we wanted to know what we have, and 95% is from 78 to 62. So the other side plus the other side of 78 is going to be only 5%. But we don't want it to know that's less than, the percentage less than 62. We only wanted to know percentage that it's above 78. So this is not going to be included. So we're going to just use the half of it. So again, 95 is between 62 to 78. It means lower than 62 plus higher than 78 is going to be 5%. And because we're only going to use one side of that 5%, it's going to be half of 5%, which is 2.5. So we could say 2.5% of men have heights above 78 inches. Next topic, we're going to learn how to find the z-score. What is the z-score? Z-score is describing how many standard deviation a data item in a normal distribution lies above or below the mean. So these values that we were looking at it before, difference of this is going to be your z-score. And finding z-score is going to be data item minus mean over standard deviations. Data item minus mean over standard deviations. Example 3, the mean weight of newborn infant is 7 pounds and the standard deviation is 8 pounds. The weights of newborn infants are normally distributed. Find the z-score for a weight of 9 pounds, 7 pounds, and 6 pounds. So remember, if we're trying for A first, in order to find the z-score for 9 pounds, we're going to do that data minus means. And mean was given in this problem as 7 and standard deviation of 0.8. So this is 2 divided by 0.8, which is going to be 2.5. So your z-score is going to be 2.5. So what does this mean? So this means 9-pound infant is going to be a little chubby with the weight that is 2.5 standard deviation above the mean. What about if 7 pounds? Z-score of 7 pounds is going to be 7 minus 7 over 0.8, which is 0 divided by 0.8 is going to be 0. So in this case, you will say 7-pound infant is the right at the mean. There will be no deviations above or below it. Then C, 6 pounds. So z-score of 6 pounds, you do 6 minus 7 divided by 0.8. So this time you have negative 1 over 0.8. You get negative 1.25. So this time you will say a 6-pound infant's weight is 1.25 standard deviation below the mean. Example 4. A student scores 70 on arithmetic test and 66 on the vocabulary test. The score for both tests are normally distributed. It's important, always normally distribute. The arithmetic test has a mean of 60 and standard deviation of 20, and the vocabulary test has a mean of 60 and standard deviation of 2. On which test did the students have the better score? So in order to answer these questions, we need to find the z-score for both. In order to find the z-score for 70, you're going to do 70 minus your mean. Arithmetic is 60, so you're going to subtract 60 or divide by standard deviations 20. This gives you 10 divided by 20, which is 0.5. And then z-score for 66. That's going to be 66 minus your standard deviations, which is again 60 over, mean was 60 and standard deviation is 2, right? And this gives you 6 over 2, which is 3. So comparing these two, 0.5 and 3, you can see that students did much better on the vocabulary test because you have 3 standard deviation above the mean, right? This is 0.5 standard deviation above the mean. Next example we're going to do is IQ. So it's a IQ test is normally distributed with mean of 100 and standard deviation of 16. They want to know what will be IQ corresponding to z-score negative 1.5. So mean of the IQ is 100. What will be the IQ that's z-score being negative 1.5? So we'll do 100 minus 1.5 times your standard deviations. This gives you 100 minus 1.5 times 16 is 24. So you will have 76. 100 minus 24 will be 76. So z-score below 1.5 from your mean is going to be 76. Part B, it's saying the Mensa is a group of people with the high IQ. That member have to have z-score of 2.05 or greater from your mean of 100. And what is the IQ corresponding to a z-score of 2.05? So basically what your IQ have to be in order for you to going into Mensa, right? So we'll do again 100. This time you're going to add it because it's a greater than your mean of z-score of 2.05 times your standard deviations. And this gives you 100 plus 2.05 times 16, come up 32.8. So then your IQ have to be 132.8 in order to go into the Mensa group.